Here we are given pizza delivery cycle times from company A and pizza delivery cycle times from company B. We are here to find out if there is a significant difference in the average cycle time to deliver a pizza from company A versus company B. We will test the appropriate hypothesis and construct a 95% confidence interval.
First, we state the null hypothesis, which we will be testing. We assume that the mu of company A is equal to the mu of company B. Next, we will state the alternative hypothesis, which in this case is the mu of company A is not equal to the mu of company B.
Before we can proceed with our test, we must check the assumptions and conditions. Our first assumption is independence. In this assumption, we will assume that each pizza delivery cycle time is independent of another.
Next is the randomization condition. Although not stated in the original question, we can assume that the sample of pizza delivery cycles is a representation of the entire population of pizza delivery cycle times between the two companies.
Next is the 10% condition, which is met because 7 pizza delivery cycles is less than 10% of all pizza delivery cycles from company A. Also, 5 pizza delivery cycles is less than 10% of all pizza delivery cycles from company B.
Next is the independent group's assumption. We state that pizza company A's cycle times are independent of pizza company B's cycle times.
Now we must make sure that the data is normal by checking the normality plots. First, we will plug our data into the calculator. First, we'll check the data for pizza company A. As you can see, it is approximately normal. Fortunately, the data for pizza company B is also approximately normal, therefore the normality condition is met.
Since all the assumptions and conditions are met, we will proceed with a two-sample t-test using S as a point estimate for sigma.
Our first step in testing the hypothesis is to find the t-score. The equation for the t-score is y bar A minus y bar B minus 0 over the standard error, which is SA squared over NA plus SB squared over NB.
Next, you will use your calculator to find the numbers to plug into the equation. You can do this by going to one variable stat on your calculator and running it on company A, where you will find that your y bar is 20.23, your S is 2.74, and the total number of pizza deliveries for company A is 7. You will do the same thing for company B to find that your y bar is 18.68, your S is 1.64, and your N is 5.
Now we'll use that data to get our final equation for t. We also use the calculator to find that our degrees of freedom is 9.82. When you plug this into your calculator, you will find that t equals 1.22.
Given our t-score, and knowing that our alternative hypothesis was not equal to, we'll make a two-tailed bell curve, one with the positive t-value and one with the negative t-value. Using our calculator, we will now run a two-sample t-test to find that our p-value is equal to 0.2508.
With a p-value of 0.2508 and an alpha of 0.05, we fail to reject the null hypothesis. This suggests that there is not enough evidence to conclude that there is a difference in pizza delivery cycle times between the two companies.
We will now construct a 95% confidence interval. Since the data remains the same, the assumptions and conditions are met, and we don't need to check them again. We will now proceed with a two-sample t-interval.
Our equation for the confidence interval is y bar A minus y bar B plus or minus t star with our degrees of freedom, 9.82, times the square root of SA squared over NA plus SB squared over NB. Using the data from our hypothesis test, we will plug it in to find that this is our equation. Our t star is 2.262.
To find our t-star, we use the table. Since our degrees of freedom is 9.82 and not listed, we use 9 instead. You go across to 95% where you find that 2.62 is your t-star. When you plug this information into your calculator, you find that your confidence interval comes out to be negative 1.3205 minutes to 4.4205 minutes.
Therefore, we are 95% confident that the true difference between the mean delivery cycle times for companies A and B is between negative 1.3205 and 4.4205.